All right, good afternoon, everyone. My name's Omar Lari. I am a business development manager at AWS. You guys are in CON330 today. This is running Kubernetes at scale with Bird. As part of my role at AWS, I get to work with a lot of our customers who are adopting our container services. And today I have the privilege of being joined by Connor Poole and John Heroy from Bird. And they're going to talk a little bit about how they're leveraging EKS to run their stack. So just a quick little overview of the agenda. We'll kind of bring everybody up to speed on what is EKS, what is Kubernetes, why did we build EKS, talk a little bit about some of the features and functionality, a little bit about the roadmap. And then I'll hand it over to the folks at Bird who will talk about what they've actually built on top of it. You'll get kind of a real-world, practical example of how you might be able to use EKS and see some examples from these folks on how they're leveraging it. So one of the questions I get from customers all the time is, what is best practices for running containers, or what is best practices for running microservices? To which I don't think there's really a solid prescriptive answer that fits for everybody, right? One person's best practice is an anti-pattern for somebody else. But we have seen a few trends and a few patterns that we think can be applied broadly to kind of all customers that are trying to move into a containerized environment, either with existing applications or net new applications. I'd say the first thing that's really important is to really automate everything from the beginning, right? So we see a lot of customers that try to do automation later on down the road and run into issues. Trying to fix something that you've already built is really, really difficult, but if you start with automation at the beginning, it helps immensely. And so this goes for everything. We're obviously pretty accustomed to automating all of our code builds through CI/CD processes, but it's really important to automate the entire stack, including the infrastructure. So things like your security, your logging and your monitoring, any of the extra tooling that you have. Try to define as much of that in code as possible so you can create repeatable processes that are super efficient and less error prone. Another one that we see customers being really successful is to kind of organize their organization into smaller groups and release code in smaller chunks more frequently, right? So you can actually deploy a lot faster, get features out to your customers at a more frequent basis. And if there's problems, it's usually a really small change to kind of roll that back as opposed to these large, 2, 3, 4 month projects that you have where you're deploying a large jar file. If there's problems, you have to bring that all out and kind of fix things. So being able to kind of form your teams and your application around these smaller teams helps both on delivery velocity and less errors when you actually do your deployments. So given this is a 300-level session, I'm assuming most people in here already kind of know what Kubernetes is. But just to kind of bring everybody up to speed, we know Kubernetes is an open source management platform for running your containers. And basically what that means is it's doing things like resource management, how much CPU and memory you have available in your cluster, how many network resources you have, and then really allocating and distributing those resources to your applications as you start to scale up. The last piece I want to touch on is that it gives you these really nice core primitives and building blocks that you would normally have to build yourself, right? So you have things like health checks, auto restarts of your pod in case of failure, self-healing functionality, all these kind of little building blocks that we'd normally have to build yourself. You can kind of take advantage of a common framework, things that all kinds of customers do already. You don't have to be unique and build your own way to bring a pod back up. It's generally a pretty generic operation. So it gives you all of these out of the box and ready to use on a nice, really simple to use API and provides a really good user experience. So here are the big ways that we're seeing customers adopt Kubernetes and EKS. I think a very obvious pattern is going to be microservices. So we know containers and microservices kind of lend very well to each other. I think early on people said you could only run containers if you were doing microservices. I don't think that that's true anymore, but it's still true that they work very well hand in hand together. Immutable infrastructure, stateless APIs, microservices are a super popular way for customers adopting EKS. Next is a platform as a service. So we're seeing this as a very emerging pattern and trend, especially amongst larger operations. Teams that have operations expertise internally, they'll build a platform on top of EKS to obfuscate some of the complexity away from their developers. So developers don't need to know everything about Kubernetes and have to write these long, laborious YAML files and deal with all these infrastructure primitives. They can basically deploy their applications, do things that's actually bringing value to the business, and just deploy that infrastructure, deploy their code on top of the platform, and the platform team kind of takes it from there for them. Gives them a lot of out-of-the-box things like logging and monitoring and security and networking, so that the developers really don't need to think about that. Enterprise app migration, this is a very popular one, especially in large organizations that have old legacy monolithic applications. They can kind of just lift and shift these and solve a lot of the problems that they have with their monolith through infrastructure. So some of the things I was talking about earlier with Kubernetes around health checking and self-healing functionality, auto-scaling. Some of these problems can be solved without actually having to re-engineer from a software level your application. Obviously, re-architecting it will give you more benefits, but you can immediately take advantage of some of these things by just moving your applications into containers. And then the last one that we saw, which is really interesting to us and was unexpected when we first deployed EKS, we saw a lot of usage amongst our P2, P3 instance types, which are our GPU instances. And we determined that customers were using a lot of open source frameworks like Kubeflow and distributed TensorFlow to run machine learning workloads on top of AWS, on top of EKS. So doing things like training their models and deep learning and then actually serving those up as well, serving the inference models all within this common pipeline. So EKS has been a really popular destination for that. So what is EKS? Every time you do an EKS create cluster in your account, this is kind of what's going on behind the scenes. We deploy a highly available etcd cluster. So etcd is the persistent key value store where all of the data about the cluster is stored. And then we deploy a highly available control plane. So this consists of all the Kubernetes components, the API server, the controller managers, the schedulers. These are all deployed in a highly available fashion and then exposed through a network load balancer to which you can then connect any of your client tooling, whether that's kubectl or any of the SDKs. And it's the same endpoint that your EC2 instances use to connect back to the control plane. So you can see that all of these things are built on top of AWS, just all core AWS primitives and services, so we're not doing anything special. It's all built on top of EC2. Some of the special things that we do on the back end are handle a lot of the undifferentiated heavy lifting, especially around etcd, things like managing and maintaining quorum in the event of failures, do backups and snapshots of the actual data that's stored there, and have the ability to do a lot of this restoration. And then we do everything in a very secure fashion. So everything is encrypted, there's a PKI, everything is protected with SSL certificates, both within the VPC and everything that's exposed back to the customer account. So a few of our core tenets. One is that we built EKS for customers to run production-grade workloads on top of. And what does that mean? So basically, just going back to my previous slide, is that every single cluster that gets created is highly available by default. There's no single development cluster. This is built for running your real mission-critical workloads, highly available by default. Second is that we're not going to fork Kubernetes, so we're not running an AWS version or an Amazon version of Kubernetes. This is the same Kubernetes that you can pull off of GitHub, install on EC2, and run yourself. So we're not doing anything different to the code. We want to make sure that our customers have that same open source experience, whether they're running Kubernetes themselves or they're running it in EKS. And then lastly is that our team actually participates in the open source community. So over the course of the last several years, we've built a lot of distributed systems, things like Dynamo and S3, obviously EC2. A lot of learnings have come around that, around operational excellence and security. So we're contributing a lot of those learnings back to the Kubernetes project and helping making that a really solid project for the entire community. So EKS GA'd in June of 2018. We did the reInvent announcement 2 years ago. 6 months later, it was GA. Just a little bit of a highlight of the features and functionality that we've done since we've GA'd. So you'll see a lot of things around regional expansion, additional features and functionalities around new versions of Kubernetes. We had managed node groups, so now we actually manage the nodes inside of your account, not just the control plane. And those of you that were keeping up on Andy Jassy's keynote yesterday, we now have Fargate for EKS GA as well. So you can see that the team's been working really hard, both on EKS, but also a lot of the open source projects as well. So we've done things for the Ingress controllers, CNI, authentication, and security. So we're continuing to innovate both for EKS and for the open source. So we were actually one of the first teams, the container services team within AWS, to open source our roadmap. So you can actually go onto GitHub and see what we're working on for all of our container services, not just EKS, but ECS, Fargate, AppMesh, and see what we're actually building. So I definitely encourage you to take a look at that. And if there's something that you would like to see that's not on there, I'd encourage you to open an issue, and we'll engage with you guys. So this is a forum for us to be able to engage with the open source community, really listen to our customers, and determine what we should be building next. Everything that we build generally always comes from a customer request. A couple highlights that you'll see from the open source roadmap, if you filter that by EKS, some of the things that we recently shipped. IAM roles for service accounts, new versions of Kubernetes. I talked about managed node groups. Fargate for EKS is actually shipped in GA now, so this deck was submitted before that actually went GA, so you see that coming soon. And then we're working on some new things. We're going to have a new CNI plugin. We're going to continue our regional expansion globally, and provide a little bit more managed services as well. So today, some of the things you kind of have to install and configure and provision yourself, so things like logging and monitoring, cluster autoscaler, we'll start to take on more and more on that on behalf of our customers so they can really focus on just building their applications. So with that, I'm going to hand it off to Connor, who's going to talk about what Bird has built on top of EKS.
All right. Thank you, Omar. All right, so can I say, who here has heard of Bird? All right, that's pretty good. Who here has ridden a Bird? All right, even better. I want to see more hands, but we'll come back next year and do it again. So what is Bird? Bird is a micromobility company, and micromobility is scooters, mopeds. It is small electric vehicles that we think will be the revolution of transportation in an urban environment. We put these things out on the street. You come up to them, you rent them, you go to your work, you go home, you have fun on the weekend, do whatever you want, but you get around in a clean, efficient manner in an urban environment. So we've been around for a little while now, about 2 years, and we've seen explosive growth during that period. It's the classic startup story of you've gone from nothing to a rocket ship overnight, but that happened at Bird. We went from 0 to 10 million rides in our first year, and it's been a year since then. We're at 0 and now 100+ markets globally, worldwide. We went from 1 engineer to over 100. So we've seen a lot of growth in a short period of time. So today's talk is about not just running Kubernetes at scale, but also building a platform on a deadline. So you're under a pressure cooker at work. You got to get stuff done. You have to do it quickly. And ideally, you end up with some delicious rice, but sometimes you make a mess of your kitchen. And so today's talk is about how mostly we ended up on the left side and we got some good dinner, and sometimes our kitchen is a disaster. So the mantra is reduce, reuse, recycle. You don't want to build everything in-house. As Omar said, managed services are incredibly helpful. And you want to lean on the community to build a platform like this at a very fast pace. So we have leaned on Terraform for all of our declarative infrastructure. We have Jenkins for CI/CD. It's tried and true. You can always find someone on the street that knows Jenkins. Orchestration, obviously EKS, that's why we're here. And finally, managed Amazon services for things like your data layer. So here's our timeline. We started over 2017 in our first ride, and then we're now to today on the far right. And you'll see the slide a few more times today. So September 2017, let's give you some backstory. We started out in Santa Monica. We have these modified retail scooters. These are just shipped over from overseas, and we're slapping a brain on top of them, and we have a single backend and a phone app, and life is easy, and you do a deploy whenever, right? It's great. So we fast forward 5 months. Things have changed. Now we've gotten to be thousands of birds. We're in multiple markets in the US. We're dealing with lots of regulations. And so we have to begin decoupling our backend. We have too many birds now to do everything in like the basic batch process or in a single API. So we have workers. And this thing starts splitting out. Life starts getting a little bit harder. So June rolls around. We've got probably half a dozen things that we're deploying on a daily basis. It's getting hard to manage. At this point, we are literally taking jars and shipping them to S3, and they're getting onto EC2 machines. There's like half a dozen engineers working on stuff. So we get to start fresh in Amazon. Everyone's dream, right? You get into a company, and you're like, all right, well, let's throw all that away and start fresh. And so we got to reinvent the wheel. That's 2 puns for the price of 1. Thank you. And so we did a hub and spoke topology. So this is your standard thing. You're going to see this in any blog post. This is running your accounts with VPCs inside, using accounts as your logical separation of controls for production versus lower environments, and having shared services in the middle. What do our VPCs look like? Once again, fairly standard. You're looking at just a web company that needs to be able to scale quickly. Don't overcomplicate your subnets. Choose a 3-layer design. You've got your public, your private, your super private, Fort Knox as we call it, not attached to the internet. And make these large and spread them across your AZs. So we built this. We're moving forward. We have our VPCs out. We're still growing every week is crazy. We're having outages all the time. You get a phone call at 2 in the morning. You wake up. And so what do you learn from this? It's roll with the punches. You want to start fresh, and you want to lean on the community for everything. That's great. But you're playing glue between all these different services. You will have outages, and you need to be okay with that. So deploying jars from S3 isn't quite working for us anymore. We've gotten past that scale. And now we need CI. So we've moved to this multiple environment world, which like we just showed you. And we decide, OK, it's time to do containers. That's the obvious next step. EKS wasn't there yet. EKS hadn't been released. It was still in private beta. So we needed something that could get us there immediately. So we turned to ECS. It's another fantastic Amazon managed service. And we moved all of our backend, millions of users, in 30 days and got it all on there, got it running quickly as possible. So why do we go to ECS? Well, of course, containers, right? Once again, we're all here for that. ECS is simple to set up. It's native. It has, that managed component that Omar is talking about that EKS is building today. ECS has had that from the beginning. And it was a smaller jump for us to go from EC2 to ECS. So we've moved forward a few months. That's about 2 months that we're talking about. So things are in a compressed timeline. So what comes next? We do to EKS. EKS is released. So 45 days later, we make the jump again. So why did we do this? Why did we leave ECS? Well, Kubernetes has better support for stateful workloads. We wanted to run things for our data team. We wanted to run large instances with persistent disks, and EKS handles this, and Kubernetes handles this upstream. EKS also handles the headaches of managing the control plane. If you've ever managed your own etcd cluster or tried to autoscale your API fleet for Kubernetes, it's not very fun, and when etcd loses its mind, it totally loses its mind. So EKS handles that for you. And then, of course, the VPC CNI driver. This is probably one of the best reasons for running EKS, is that comes out of the box, wired, ready to go. Your pods are in your VPC subnets. So what have we learned from running EKS at somewhat of a scale? What do we think is a best practice for everyone here? And like Omar said, there's no prescriptive answer. This is what we think. So the first step is prune your clusters down. When you spin up a cluster, there's things in it. Those things in it are there to help you get started, but they're also something that you don't declaratively own. So the first thing when you create a cluster, rip everything out of it that you can and build it up yourself. You want to use large workers. Use large worker nodes that have optimal bin packing. That way you can shuffle things around. You might want to isolate these on instance type, instance class, a memory node, a compute node, but make them large. You rely on cluster autoscaler and horizontal pod autoscaler to handle cluster sizing. These are upstream projects. They work well in Amazon. They have native support. They'll work for you. And finally, Calico for network policy. It's basically the default. It comes in half the Helm charts already. You don't have to do extra work. So how do we orchestrate the orchestrator? How do we manage our Kubernetes clusters across our accounts? And as we said earlier, Terraform is the answer. And so this is what a module looks like for us. We've taken all those individual pieces, the nitty-gritty of managing a cluster and deciding which components, cluster autoscaler and cube to IAM and all these different pieces, and we've wrapped it into about 20 lines. And this is your basic pieces. This is, what are we using our ingress SSL certs? What subnets are we going to deploy this in? What's the name of the cluster? And that's about all you need. So we spun a cluster, and now you're going to end up in the bookshelf on the right. You're going to be trying to find a comic book, and you can't know where anything is. Someone, did one of those curl pipe to bash commands, and there's 12 pods running, and it's like WordPress 2, and you're like, what the heck? So cluster sprawl is real. Don't just spin up clusters and say, okay, we're done. The cluster's there. We're managing the components. Use namespaces. Help clamp this sprawl. Make partitions within your cluster that align to your largest logical business grouping. For us, this is individual services. This is, service foo might have a few deployables, and we'll talk about that in a sec. So, of course, choose this wisely as well. Every application probably shouldn't have its own namespace, because then you're just in the same boat again. Choose a deployment strategy. So, when you're deploying things to Kubernetes, there's a million different ways. Everyone's got their own tool. You can render things through templates, or you can just kubectl apply. Our answer is minimize the cruft by using one deployment strategy, and we chose Helm. Helm is flexible. It has some nice templating, and most importantly with Helm for us is that Helm provides a clean API that we can code against. We can write our own add-ons and additions. We can pull down the Helm protobufs. We can look through the config maps. We can walk a graph. We can see the lineage and make decisions based on that. If you want to write a mutagenic webhook controller that reads the previous state and makes a transformation, you can do that with Helm because all that information is already in your cluster. You'd have to be crazy to run stateful mission-critical systems on Kubernetes. You've all read this blog post. You've seen someone important talk about it. They've told you don't do it. And we're here to say, the first workload we ran was Kafka. You can do it. And the answer is you can do it on Kubernetes. And you can do it because Kubernetes and EKS is stable. And the platform has progressed to a state where you don't have to worry about these individual disks anymore. So what have we done? We went 216 nodes per cluster. So we're building this pipeline. We're building this platform on which the rest of the organization can design themselves. And data team had a need. And they were our first real client. So out of the gate, we went big. We said, let's get the widest clusters we can. Let's get 500 gigs on disk on each one of these. Let's put multiple Kafka clusters in each Kubernetes cluster. And then we let it go. And then, of course, you get the call at 11 p.m. and you pull over to the side of the road and someone's like, things are out of disk. So this is a reality. But once again, Kubernetes comes to the rescue, provides a clean API to resize these disks on the fly. So data team comes on board. We have Kafka in there. Kafka is running, and people in the rest of the org are starting to go, all right, this works. We like this. The data team seems to not even have to manage Kafka, which is typically a headache. Like, let's do this for the rest of our application. So like any good startup, we had built a monolith. That's what you do, right? You're a startup. You got to move fast. You build a monolith. Now it's time to decouple the monolith. So when we start decoupling the monolith and moving over to Kubernetes, we found a few pieces of advice that we think will help everyone trying to do a same transition. First is organize your apps, your data, your configs into a standard data structure. Choose a tree, choose a graph, choose a balance tree, choose whatever, something that you're familiar with as a software engineer that you can then write your own deployment logic, you can write your own security logic against in a standard format. Co-locate your data sources. If service foo needs an RDS database and a bucket, put it inside the service foo namespace. Put it inside the service foo config namespace. Make sure that those teams have access to those objects. And if you're feeling risky or you're feeling permissive, give them access to production. Let people shoot themselves in the foot. With Kubernetes, you can move fast enough. When you shoot yourself in the foot, you can get it repaired overnight. So another question we had when we started building this platform is to mesh or not to mesh. And you'll hear a lot of talks about this. You go to KubeCon, this is pretty much every conversation, is how you need a service mesh, you don't have one, you're doing it wrong. And the answer is, maybe not. Do you really need this? Are you really at that scale? And I'm sure there are many of you in this room that are at that scale, and you need it. But Bird wasn't, and Bird still isn't today. And we have millions of users and thousands and thousands of requests per second. And for us, Ingress Nginx was good enough. This comes off the shelf. Once again, it's supported natively in Ingress. I have experience with Nginx, so does half of our department. So we can jump in and help, and we can contribute back to the controller, and it works for us. It's simple to set up. You can run it in Minikube, run it in CI, run it wherever you need. So let's go back to the timeline. Everything we just talked about, that's all done in about 2.5 months. So everything's running on a very compressed schedule at Bird. So far we've talked about the software side. And that's great, but Bird's a transportation company. We have vehicles. So let's talk about those. These vehicles are an always-on IoT network. These are all over. Here we've got the Bird 2, our latest model. These things need to be available at millisecond latency from our back end at any time. We have to be able to talk to them, lock them, unlock them, put them in a ride, sound the alarm, etc. So we've talked a lot about how reduce, reuse, recycle is the mantra, and you should lean on that if you want to build a platform in a year or less. But there's also the reality that not everything will work out of the box. And for us, the standard kube proxy flow for TCP traffic wasn't good enough. We needed something that could have infinite socket life. We needed something that would work no matter what was going on in our cluster. So enter the NLB attacher. This allows us to directly attach pods utilizing the VPC CNI fabric that EKS gives you to your network load balancer. You get lower latency, it is direct transit, and most importantly, infinite socket life. We never have to worry. If a pod is up for 30 days and a bird is connected for 30 days, great. Nothing will ever shut that down. So this is a 300-level talk. You guys all like Kubernetes, and part of the reason that Kubernetes has become such this operating system for the cloud is because Kubernetes is extensible. You can add on your own pieces on top of Kubernetes. So we're going to talk about how we've done that with a controller. So a controller is the main controller loop inside, and this is how Cluster Autoscaler and many others work. And what do you have? Some basic components. You have a list watcher. This is looking at resources in your cluster and sending you deltas saying this thing has changed, this thing has been deleted, et cetera. You keep that in memory in an index cacher. Then you have a work queue that processes the individual events, and this work queue processes the events and sends them over to your multiple handler functions to do whatever you need. So what does a controller look like? It's simple. You have your Kubernetes API client. You have a queue, informer, your event handlers. This is relatively basic stuff. On the bottom here, you have your label selectors so that you can provide easy access and caching inside the Kubernetes API plane to only see the objects you care about. And then you can have an annotation. What's a handler? Once again, simple. It's a basic CRUD interface. Everyone's seen these 1,000 times. Adding pods. So how do we do this? And this is an example of our pod creators. This is our C in CRUD. And so we simply look at the pod. We say, does this thing have an IP address yet? Has the VPC CNI assigned it? Is this in terminating state? Do we need to discard this right now? Because we get these different updates. And then we add it to the target group. So from Bird with Love, we'd like to open source this today. It's helped us a lot. And in the mantra of reduce, reuse, recycle, we hope you guys can reduce, reuse, recycle things that we've built. So it's up and it's live today. Future support is pod UDP, direct attachment support, which is something that's also not in the community today. And then target group creation and control. And then maybe some tests. We'll see. So timeline recap. So everything we just talked about, that's a month. So things are moving quickly. This is what we're here to talk about, is how can you use EKS to build things fast. So we built the platform, data team's on, the monolith is decoupled, we figured out how to get our IoT layer there. Now what are we running into? We're running into maturity problems. And so we're running into how do we clamp state drift? This is the works on my machine, chuck it over the wall, it's ops problem now. I don't know what's going on in your cluster. And the answer is you're never going to solve this. That's a continual problem. Keeping a distributed system in check is always challenging. So you want to use the carrot, not the stick. You want to give everyone in your organization tools that they can run locally, tools that they can interact with from their machine, that reduce your entire graph across your clusters and across your environments into few pieces as possible. So when you are standing up a new service or system, you want to use this, you don't want to use, chain together 5 different tools. If you can, do it all in one tool. And if you're starting out and you're starting fresh, like Omar and we've talked about, is consider using CRDs to represent pieces of critical infrastructure. This is a new thing that's happening in the community quite a bit. There's a lot of interesting controllers out there that it'll spin up your database for you native to Kubernetes. But be realistic. Today, Terraform satisfies those for us. We have many different providers. We work across Vault and our CDNs and Helm and Kubernetes, and Terraform has plugins for all of these, and it works. But if you go down that route, there's some gotchas. And the biggest one that we've encountered is that the interface between Helm and Terraform is poor. Raise your hand if you like writing YAML. Yeah, nobody, raise your hand. It's a white space language, it's a brittle contract, it breaks, and you're gonna encounter that. That's probably one of the most challenging pieces about interacting with Kubernetes. But look to the future. There's some very interesting projects coming out from Amazon. There's the AWS Service Operator that I encourage everyone to go participate in the section about and contribute to what its design will be. And then Rancher has something that's usable today, which is how can you run Terraform as a state inside a controller. So we've built a platform. We have started to go over the challenges of maturity. So you need to understand your users. And we hear DevOps is great, and everyone wants to do DevOps, but DevOps is a goal. It's a moving target, and it's important in moderation. Just like no one writes for writing YAML, maybe everyone doesn't care about cluster autoscaler. So when you're building your platform, remember that Kubernetes evolves quickly. Kubernetes evolves very fast. It has releases every few months, and abstraction will be your friend. Keep your internal platform a thin layer that can abstract this fast-moving target away from your users. And finally, like we said before, tighten the feedback loop. Users have to see results during their local development cycle. They can't wait for Jenkins to spit out an error 30 minutes from now and then throw up their hands. They'll never get anywhere. So how have we done this, and what does this look like for us? This is a bird service. We have abstracted this into a very simple declarative structure. We have a service. We've asked for dependencies. This service wants a database, and it wants an SQS queue. We have our deployable. That's an HTTP type. It's written in Kotlin. We support Golang and Python as well. And that's it. You type that out, and now we will stamp out everything else that you need to make your service live. So we're moving. We've built this platform, and now we want to talk to you about what actually runs on this platform. And why has this been valuable for us? So one of the poster child things for our platform that is much more challenging to run on EC2, run on ECS, run anywhere else, is Flink. So for those of you that don't know, Flink is a streaming library today that exists for taking in streams from Kafka, Dynamo, et cetera, and then collating these over sliding windows and memory functions. And here we can see a standard graph for us. We have inputs coming in on the left. We have mappers that combine multiple event sources. We have event bus topics. They go out to syncs, maybe to S3, maybe to Elasticsearch, et cetera. And then finally, we get to government dashboards. And this is how a lot of our governments will get their real-time analysis of where are the vehicles in their market. So why did we choose Flink? Why is this the thing we're talking about? Well, obviously, we need data in real time. These scooters, we have far too many for batch processes to be effective. We can't be finding out about a state transition every 30 minutes. And the state transitions that do happen for us are very latency sensitive. If a bird goes from in ride to not in a ride, we need to know right away. Or if it gets moved in an unlicensed manner, we need to know. Additionally, it has the best in-memory state management, snapshot, and debugging. There's very few of the streaming frameworks are as rich in a save point and checkpoint style as Flink is. And then, of course, native Kubernetes support. The task managers and the job managers are cluster aware and can find each other within a cluster when you spin them up. So maybe why not Flink? Because we're being reasonable here. Flink is new. Bugs exist, and you'll find them. If you can't afford any downtime and you need something rock stable, maybe wait a bit for Flink. It's getting there, but it's not quite there today. Then Kafka and Flink have silent partition issues. If you're running very wide clusters and you have lots of data coming in, if it's all not moving at the same rate, then you will have some partitions with their watermarks falling behind. So you need to be aware of when to close your windows, what data to drop, how you're going to handle heartbeats. And then, of course, if you're not already in Kubernetes, you already have a large managed Hadoop cluster, you've already got Spark running somewhere, maybe that's your solution for today. It's always about being reasonable. So you all have heard us talk about a tech platform and what we've built and our recommendations on how to do this on top of Kubernetes. But this doesn't make bird money. This is a cool tech talk. And so to find out how your business can find this to be interesting and something that they want to sponsor, I have John Heroy here, engineering manager at Bird, who's going to talk about how his team uses Kubernetes.
So what I have here on the right is all the locations that were reported by a single vehicle over roughly a 24-hour period. So if you're taking a look at this diagram, where do you think the bird is? Where is it? I'll give you a hint. The gray shape is just a building. It's one of our in-market service centers, and the rest of the space is just some outdoor space. So because the bird is inside, there might have been bad weather that day. It's not jumping in and out of the building. It's not moving around. It's just sitting inside the building. Each individual location point and each individual signal does not tell the entire story. However, if we look at multiple signals over a period of time, we can compute a more reliable result that we can use to drive some kind of business side effect. Recently, we launched several service centers, in-market service centers, in markets where we see high ridership. So we had to develop a more accurate location processor to determine whether the bird was in the service center or outside the service center. We did not want riders, so in our service centers, we go out and we pick up birds, we bring them back, we repair them, we recharge them before we put them back out on the street. But we don't want riders to see them on the map because this would lead to a poor rider experience. We don't want riders to walk up and try to find a bird that isn't available for ride. So let me give you another example. How many of you, just quick show of hands, have ever ridden a bird and then noticed that it suddenly started beeping and slowing down? Anybody? Okay. So you may have encountered what we call a speed limit zone. There are many different features and aspects of our business that depend on having reliable signals to know, for example, when a bird is in a certain polygon or if it's a certain distance away from a point of interest. Stream processing is an incredibly flexible solution for processing signals and producing side effects. So we have a global event bus in the form of Kafka, which talks to pretty much every other component in the system that contains some semblance of business logic. And it already contains a catalog of raw events, so say, for example, the bird's location, the bird's battery, and also user interactions, like the user clicked a button. So we did have to go through an instrumentation exercise in order to actually populate this catalog, but populating the event bus has become part of our core engineering culture. So now a bird engineer can write a Flink job, depend on a single event in the event bus, perform some kind of computation, output another event to the event bus, which in turn can be consumed by any other component in the system. It's a really flexible way for us to share business logic between features and teams without having to introduce a complex web of dependencies for each additional thing. Everything is written out to our data warehouse so that we have complete observability over everything that's flowing through our system for analytics. Okay, so we're getting to the fun part because in just a moment, we are actually going to write and deploy a Flink job. So this Flink job, we are going to use the sliding windows feature. We are going to declare overlapping windows of time. Each window will collect all of the bird locations that were reported during that period of time, compute an average, and then output the result back to the event bus. So I already took a Flink job based on this design. I applied it to our original example. Let's take a look at that again. So I turned this into this, which is not perfect by any means, but we have a much higher level of confidence that the bird actually stayed within the building for the duration of that time. So now I'm going to turn it over to Connor to start walking us through how a bird engineer would start developing this Flink job from start to finish.
All right. So let's say I want to make this Flink job. I've got a request from the business, and someone has come in and said, we just launched this new market, this new service center, and like half of our birds, people are banging on the doors trying to get them out there, get these people away from the service center. So we need to make this job, we need to do it quick. So I make a new folder, service-derived location. It's a little bigger. So I open up my manifest, right? And we have here this deployables array. So let's go ahead and add a new deployable. Add this location averager, right? Okay. And we say, dependencies, this is just a Flink job, so we don't need any dependencies. Language, all of our Flink stuff is written in Kotlin. We are primarily a Kotlin shop. Name, Kotlin. And then let's say type, name, Flink. Let's see if I can type. All right. So here we run our CLI tool. This is bird tooling service. We want to update service name, service derived location. All right, great. So we created a bunch of files. So what does that look like? So now in this directory where there was just a manifest before, now we have Helm. So let's take a look. We have our Helm chart, right? This is our basic Helm chart. Then we have our Jenkins file. We have our location averager. This is our individual source file for this. And so here you can see there's our Helm chart for the individual Flink job. Then underneath source, we have our default stamped out Flink template, all in Kotlin. Then we got our Terraform for an individual person to write for the individual API or Flink job. And then we also have Terraform for the deployable and the service scope. So if we had requested a database at service scope, that's where it would end up. Okay, so I've stamped all this out, and now I'm going to hand it over to John, who's going to show us how do we actually write something in Flink.
Okay, so we're taking a look at our Flink job here. I've filled in some additional boilerplate just to point us to the right stream where we're actually going to be getting the raw location signals. So that's called bird track. That contains a lat long. So the first thing that we've done is we've filtered for valid locations. And now we need to actually declare a keyed stream because we need to tell Flink what entities it cares about to look at within each window. So in this case, I'm going to use the bird ID. And then next, I'm going to tell Flink what windowing strategy to use. So for this case, we're just using processing time. For your use case, it may make more sense to use event time. So let's just say I have a window which is 60 seconds in length and staggered by every 30 seconds. And then the final step here is that I need to process the window. And this is really the meat of the entire Flink job. This is where I take all the signals that were collected, perform some kind of computation, aggregation, and produce an output. So here I've created something called average location function. You may have a different use case, which is some other kind of real-time aggregation, a max, a count, an average. So this could be the number of user clicks received within an hour sliced by the user, or the number of ad impressions served by geography per day. Now Connor's going to show us how to deploy this on our Kubernetes cluster.
Mm-hmm. All right, and we're going to spare everyone actually watching Jenkins build that. So we built it this morning, or 12 hours ago, last night, midnight, and deployed it up to our cluster. So if the demo gods smile on us, we have internet. Do we have internet? Yes, we do. Great. So here we can see, we're taking a look at our pods. So this has already been deployed into that namespace we created earlier. So we have our job manager running, and we have our task manager running. So all this was stamped out and deployed by Jenkins. Simply commit, the Jenkins file already existed. So let's go ahead and take a look at some logs coming out of this, show you it's actually working. It's doing stuff. You guys got all that? You read all of it? Great. Fantastic. Okay. So what is it actually doing? So over here, we are reading a large stream of events, right? This is coming out of Kafka. This is a Kafka consume, reinvent demo events, just piping this in. We're taking a look at a few of the pieces. So here we can see this bird's coming in. It's got some signals that are the same. Some signals have lost some precision. Maybe it's got another signal here, some precision loss. It's bouncing around a bit. It's like that bird we saw earlier. But over here on the right, we have that same bird that's being emitted in these windows, and we're seeing how many tracks are emitted in those windows. And now we see that these numbers aren't moving nearly as much. This is much, much closer. So why is this important? We've just shown you that if your business needs to take something and you need to build it on right now because you need to solve a problem, you can use EKS, you can use Flink, you can use persistent data stores running on Kafka, all running on top of Kubernetes. And in about maybe 5 extra minutes to build and deploy, 10 minutes, you can actually have something immediately on top of your system providing value. So join the flock, jobs.bird.co. You want to move to sunny Southern California and ride birds year-round? please apply and hit us up on Twitter or email or whatever. And thank you all for coming out. So now it's time for Q&A.
If there's any questions, be happy to,
yell them.
yeah, might have to yell them. I don't know that we have a mic. We've got 10, 15 minutes left here. Yes?
So I wonder if you guys have been taking a look in Quick, which is a protocol from Google. It's QUIC. Before calling it
Yeah.
Quick, right? You see there is a feed. Your business case, like
Yeah.
mobile devices, switching from networks. I wonder if you guys have taken a look in this protocol and tested it.
So
Can you repeat the question?
yeah, sorry. So the question was, have we looked at all into Quick, QUIC, which is, comes from people call it HTTP3, and it's like HTTP over a custom UDP protocol. And the answer is yes, and we use it. We use Quick today on a lot of our edge communications up to Cloudflare. And then Cloudflare has an interesting ingress controller to proxy that into your cluster as well. And they have interesting mobile SDKs that we integrate into our apps. We're not using it for our IoT layer because it's not quite ready for the embedded world, but certainly getting there. Yep, correct.
I'll bring the mic over.
So how do you guys deal with restore and backup of the EKS cluster?
So the EKS cluster itself is managed by Amazon, so we don't have to worry about the etcd portion of that. That is backed up, and they'll handle restores and updates. As for the things running inside of it, our stateful sets, those are all backed up by a controller that we have running that looks at labels on the individual volumes and will snapshot them based on the labels.
More like the DevOps day-to-day.
Sure. So this platform was mostly built out with about anywhere from 2 to 3 active engineers working at any given time. So relatively small number.
So what challenges did you face for running Kafka and Kubernetes? Did you do anything special over there, or any special operators that you use?
Yeah. So one of the interesting things we ran into a few. The first one is that Kubernetes doesn't provide a great network limiting feature. So if you're co-located with a really noisy other service, and then you're trying to pump a bunch of stuff out of a topic someone read from offset 0, we had sucking through a straw, so to speak. So we ended up isolating Kafka to its own set of node groups. And we think that's a good advice, is take all your Kafka and lump them on their own node groups. It doesn't necessarily need to be one pod per node, but at least that should be managed well. Another one we ran into was rack-aware scheduling. Kubernetes, I think it's still true as of 1.15. It may have been rewritten in 1.16 with the scheduler. Does not give you topology guarantees. It only gives you topology best effort. So if you're trying to do rack-aware broker scheduling, you get some imbalance. So you might end up with 2 partitions on the same broker or on the same node, not necessarily spread across the same AZs. But you can fix that by running with replication too. And then the other issue we ran into is disk throughput. You are attaching a single EBS volume. You max out at 300 megabytes per second out of that volume. And that can be problematic if you have an outage of a whole node and you lose something, or if someone wants to do a huge backfill. And so that's how we have separated into clusters based on use case. So we have a latency cluster with very tall, fat disks that is not meant to take a bunch of data and ship it around, but is meant for a very quick few partitions in the topic. And then we have throughput clusters that are very wide, 216 nodes, and those can pump gigabits and gigabits across the clusters. So.
Flink in Kubernetes. Do you have high availability for a job manager, and how big your cluster? And last things, what's the biggest challenge with Kubernetes? Because it's not 100% supported, Flink support Kubernetes still.
So the first part of that is, the job manager highly available. We rely on Kubernetes to spin up a new job manager when the current job manager dies, because the Flink task managers can live for a little bit, but we use Zookeeper as the coordinator. So it's more of a hot standby kind of scenario where it keeps a lock, knows where the last checkpoint is, dies, back, restores, and we have a persistent disk mounted on the job manager so that the RocksDB storage is still there when it comes back up. And then I believe you asked about what was our largest job that we have. Let's see. I mean, hundreds of nodes, hundreds and hundreds of jobs, and some of our largest have like task slots in the dozens.
Two questions.
Sorry, a little bit louder. Yes. Yeah. So the first part, how do we manage rotating these nodes with security patches? Amazon publishes the Kubernetes AMIs. That has bit us a few times. That is someone else publishing those and some changes get made. But we pull those in via Terraform, and we automatically select the latest version. And then every time we run Terraform, which is on a daily basis, that'll update it, and it'll update the launch configuration. And then we use Node Problem Detector and Drano to determine if the AMI is out of date, mark the node as cordon, drain it, autoscaling group or cluster autoscaler will bring us up a new node. And so that way, every time Amazon publishes a new node with all the security patches, it rolls out to our clusters. And then the second part was about security patching. We have X-ray and Artifactory for some of our jar scanning. As far as the Docker image scanning, we don't have the best story around that today. Our AppSec team would not be super happy that I'm saying that. But, but our story there is, we build from latest of the base Docker images of base Debian. And so we pull those in as frequently as possible.
Yeah, just a couple product things on that as well is we recently released managed node groups, which will allow you to upgrade the version of the EC2 instances that run inside of your cluster. So it'll take care of all of the Linux CVEs, container runtime, all of the Kubernetes components, kubeproxy, and kubebutton update those for you on a rolling fashion. So I don't know if you guys have had a chance to implement that. And then secondly, ECR also now supports image scanning for CVEs as well. So if you haven't seen that, that's
so we have that too, apparently.
Featured. Yep. I think we got time for two more, I think, here.
You seem to have done a very good job with this, so well done. I just wondered what is next for you? What's on your roadmap in the future? What are the things that you aspire to do in the next 3-6 months?
Sure. I think, like we said on stage, maybe we didn't need a service mesh 6 months ago when we built this platform. We are starting to get to the scale where we need a little bit better of a security posture around segregation. So a service mesh is likely coming to part of our infrastructure. And then a big one that we've been working on for a little while and we hope to really polish up is fully ephemeral environments. So now that we have all this declared in our own platform and we know how all this is expressed and we can build our own CRDs, is that we can take all of Bird and spin it up in a single namespace in another cluster and use our hub and spoke to ship test data over and sanitize that. And so that's a big project for us right now that we, I'd like to say it'll be done in a few months, but call me in 6 months and we'll probably still be talking about it.
Got one over here, Connor.
Sure.
I have a question following up on the backup question that you responded to earlier. So since your application is stateful application, and you mentioned that you take PVC's snapshot for backup, how were you ensuring the consistency of the that backup that you were taking across the application?
How do we ensure that the backup is
application? Yeah, consistency for it's consistent.
It's mostly finger crossing. To be totally honest with you, we have never actually had to use it. We've never lost an EBS volume. That did just happen in US East 1, so we should probably practice that.
Okay, I think we got time for one more here.
But the answer too is, if we did need to use that, you can always take a volume claim template and you can restore from an EBS snapshot ID. So that would work in a pinch if we needed to do it right now.
So we have a similar setup where we deploy Flink jobs on the fly, but a lot of time, both a streaming setup and a batch setup. And early on Kubernetes with the earlier CNI version, like 1.3 or so, one of those series, we'd have an issue where it would get stuck in some pending state waiting to get an IP for the pod that was coming up. The open source tool that you mentioned, is part of that, does it provide tooling to make sure that those IPs are warm and ready before it releases that node into the...
No, unfortunately it does not, and we've also been bit by that. Our solution to that recently has been to schedule nothing in a subnet smaller than like a WAC 18. And then IPAMD doesn't seem to have as many problems fetching a hot IP from the pool. But yeah, it's not fun when it happens. We usually just shoot the node when that happens.
Let's do one more here if we got one more. No? Think we're good? Awesome. Thank you very much, everybody.
All right. Thanks, everyone.